Welcome to Study Loop.
So this is the solution for problem 17 and, problem 70 in chapter 17. So here we're told that we're doing a titration of propanoic acid with potassium hydroxide. So we have 30 milliliters of 0.165 molar propanoic acid and 0.3 molar KOH, potassium hydroxide. So we're supposed to calculate the pH in volume or at specific volumes of added base. In some cases, we might need to calculate the volume as well. So 0, 5, 10 milliliters, equivalence point, half equivalence point, 20 milliliters, and 25 milliliters. And then we will sketch the titration curve. So first, before we calculate any of the pHs, let's see what our initial moles is. So we're told that we have 0.165 molar propanoic acid. And if we multiply that by the volume, 0.03, not 0.003, we will get moles. So, this is equals 0.00495 moles of acid, propanoic acid. So this here we're going to use later on. Let's go to our first point, which is 0 milliliters. So when no base has been added, what is the concentration? So since we're dealing with a weak acid here, we're going to do an equilibrium problem. So we're going to draw propanoic acid as a generic HA, reacting with water to form A- and H3O+. So initially we have 0.165 molar HA, none of the products. So we subtract X and add X to the right, and we get 0.165 minus X, X, and X. So we can get the Ka from the table in the back as being equal to 1.3 times 10 to the minus 5. And this is equal to our products over our reactants, so X squared divided by 0.165 minus X. If we use our approximation that X is small, we can eliminate the minus X, and we can solve that X is equal to 1.46 times 10 to the minus 3, and then pH will be equal to 2.83 if we take the negative log of our X value. So that's our pH for the first point they ask us for. Let's go ahead and do 5 milliliters. So here we're going to do an equilibrium problem again, but now we have base present, so we're reacting with OH minus to form, once again, A minus and water. So our initial will be the moles. It's not the concentration, but because we can just work in moles now, so 0.00495, the moles initial that we calculated at the beginning. Our initial moles of a hydroxide will be from multiplying the volume, 5 milliliters times the concentration to get 0.0015, and then no initial A minus. So we subtract 0.015 from both sides, or from the left, and then on the right we add 0.0015, and our equilibrium will be 0.00345, 0, and 0.0015. Now we can do a Henderson-Hasselbalch equation, so we get pH is equal to our pKa, which is the negative log of this, which is 4.89, plus the log of the base over the acid, 0.0015 divided by 0.00195. Excuse me, 0.00345. And that will give us a pH equal to 4.53. Okay, so we're going to open up a new page here. And we're going to do 10 milliliters. Now 10 milliliters, we can piggyback off the previous one where we subtracted 0.0015 from the initial moles of acid. Now what we need to do is realize that we're going to have HA, OH minus, A minus, and H2O. So we initially have 0.00495. We're going to have this time double the base as from 5 milliliters. And we're going to have no initial here. We have change. We're going to subtract 0.0030. And our equilibrium will be 0.00195, 0, and 0.003. So we can calculate our pH the same way we did for 5 milliliters. It's going to be 4.89 plus the log of base over acid. And if we do this, it'll be equal to 5.08. So the next point that it asks us to calculate is the equivalence point. So at the equivalence point, what we need to check first is the volume that we need to reach the equivalence point. So to reach the equivalence point, the volume we're going to need to match this number of moles from hydroxide. So if we can divide this value for moles divided by 0.3, which is the concentration of the hydroxide, and we get 0.0165 or 16.5 milliliters. So this is the volume of our equivalence point. Now what about the pH at the equivalence point? So to do that, we can go ahead and set up an ice table. So now that the only thing we have present is actually our excuse me, the only thing we have present is the conjugate base. So we can do A minus is going to react with water to give HA and HOH minus. So our initial will be the initial that we had before, 0.0495. And our change will be minus X plus X. So here all the acid has been neutralized. All the acid has been neutralized by the hydroxide, and all that we have present is this. So that's why we're doing equilibrium problem in this way. So if we go ahead and solve, we actually put the concentration. So the concentration would be, we need to divide by 46.5. So we had 30 initially. So now our total volume is equal to 46.5 milliliters. And if we take that into account here, we put in our concentration and not the number of moles. Because we're going to use the values that we get out to calculate, take the negative log right away, we're going to put in here 0.11, and that's going to be our value for molar. Okay, so our equilibrium will be 0.11 minus x, and then x and x. So we get our Kb by taking the negative, dividing 1 times 10 to the minus 14 divided by the Ka. And we get our Kb is equal to 7.69 times 10 to the minus 10 is equal to x squared over 0.11 minus x. And then when we solve for x, we get x is equal to 9.20 times 10 to the minus 6. So this here can give us POH by taking the negative log, and we get 5.04. And then we can go ahead and go to pH, and that would be equal to 8.96. So that's at the equivalence point. Now let's look at the half equivalence point. So at the half equivalence point, pH will be equal to pKa. So since pH will be equal to pKa, we know we've already solved for the pKa, that's 4.89, and then the volume will be half of the equivalence point that we just calculated, so 16.5 divided by 2, and we get 8.25 for the volume. Now it asks us to calculate 2 more points, 20 milliliters of added base. So at this point, we have the base being dominated, the strong base. So we need to calculate the excess hydroxide. So at 20 milliliters, if we multiply the volume times the concentration, we get that we have 0.06 moles of OH. Now the question is, what is the excess? So we subtract the initial acid from this, to get the excess strong base that we have. Now this is moles, so if we divide by the total volume, which is now 50 milliliters, or 0.05 liters, we get concentration, which is equal to 0.021 molar, which can give us POH by taking the negative log of 1.68, and then by subtracting from 14, we get pH is equal to 12.32. So for the last point, we can just say 25 milliliters. We had the excess, we had excess of this present, so 0.00105. And we can look back over here to see how much moles we had, this much moles present when we added 5 milliliters. So all we need to do right now is add that much 0.0015. So this was excess when we added 5. When we added 20 milliliters, when we add 5 more, this is the excess. So when we add these up, we get 0.00255 moles of excess base, excess hydroxide. And we can divide this by volume, which is now 0.055 liters, to get concentration, which is 0.046 molar. So this will lead to a pOH of 1.33 and a pH, if we subtract from 14, of 12.67. So we're finally ready to plot the whole titration curve. So let's draw our axes. That was horrible. It's not a straight line. So we're going to have volume of base. We're going to have pH. And we want to go from about 0 to 25. So let's put our points down. Our first point that we calculated was 0 milliliters of base and a pH of 2.83. So we're going to have a point around here. Our second point was 5 milliliters and 4.53. So a point around here. 10 milliliters was 5.08. So about here. And we had our equivalence point at 16.5, which gave us a pH of 8.96. So roughly around here. Then our half equivalence point was 8.25 milliliters and 4.89 pH, so roughly here. Then our 20 milliliters gave us a pH of 12.32. So we're looking at a point around here. And then 25 was 12.67, so approximately here. Now we can go ahead and draw our curve. We know that when we're titrating a weak acid with a strong base, we usually have like an initial jolt here due to dilution, and then it levels off and goes flat for a little bit. And then we see a dramatic rise and flattening off. So they should be something similar to what the curve should look like.